Hi, today I'll be talking to you about the DataJoint element for Miniscope calcium imaging. Before I begin, I would like to draw your attention to the elements.datajoint.org page, which is our main page for the DataJoint Elements project, which is a NIH-funded initiative to build data workflows for neurophysiology. And one such workflow is the DataJoint element for Miniscope imaging. All of our repositories are hosted on GitHub. So the workflow Miniscope alongside the element Miniscope are both hosted on GitHub. And that's what we'll be reviewing today. So the workflow Miniscope comprises of 4 elements: element lab, animal, session, and element Miniscope. The data pipeline looks like this. So you have the subject and session table, and then the tables related to the Miniscope elements, including the recording table, which is where you specify which recording is taking place and the directory where the data is stored. Recording info, which stores metadata about the recording. Tables about the parameter sets that you'll use for your analysis. Processing task to set up a analysis to run. Processing, which actually runs the analysis. And then these downstream tables here include the motion correction table, which stores the shifts for rigid or non-rigid motion correction, as well as the segmentation mass and fluorescence traces and deconvolved neuronal activity traces. So this workflow is configured for use with data acquired with the UCLA Miniscope and analyzed with Kaiman. So now I'll switch windows to Visual Studio Code, which is the IDE or integrated development environment that I'll be using today. I just scrolled up in the notebook that we'll be going through. And so I'll be going through 03 process, this notebook here. And I'll be showing you, we'll be working with data from subject 1, session 1, and this is how it's organized. And then there's one example AVI file for this data, the metadata JSON file, timestamp CSV file, and then the Kaiman results, which I've already run. Those are stored in an HDF5 file. So the first set of cells here imports the relevant modules. So first we actually change directories to the base repository of workflow Miniscope here on the right, so that we can access the DJ local config JSON file, which has the credentials for the database we'll be connecting to. And then I'll be importing DataJoint, and then from the pipeline script, I'll be importing the relevant modules. So this pipeline script sets up your pipeline to be set up on the database, to be instantiated on the database. And then you can see here that I'm connecting to our tutorial-db.datajoint.io database. In the next cell, I'll be using dj.diagram to plot out the diagram for the workflow Miniscope. And this is very similar to the diagram I just showed you on GitHub. One nice thing about this diagram is that it's interactive, so you can actually hover over it and see what are the primary and secondary attributes, and specifically what are the foreign key references. So in this case, Miniscope recording info has a primary attribute of Miniscope recording. And so that's its foreign key, that's its primary attribute, primary key. And the secondary attribute are below that dashed line. And so it includes the number of channels, frames, pixel height, and so on. And the other nice thing about diagrams is you can see the entire pipeline and how data flows through it. So we start at the top. Subject data is stored in the subject table. Session metadata, including the session date time, is stored in the session table. Recording is a manual table in green here, and it's where you specify the session that you run, as well as specifically the equipment, the acquisition software, and the recording directory. So where is your data stored? And in this case, if we go back here on the right, it's going to be stored within the subject 1 and session 1 directory. We'll dive into these other tables in more depth in the coming cells. So I will skip over them for right now. So we can see using heading that the subject table has the subject as a primary key, and then gender, birthday, and description as secondary attributes. So we'll use the insert method, insert one method to insert one entry into this table for subject one. And for the equipment table, we'll be entering in the equipment that we used for this recording. So we use the UCLA Miniscope, modalities Miniscope, and then the description. The session table has a foreign key reference of the subject table. And the other primary attribute is the session date time. And so we'll be creating a dictionary called session key. And the dictionary comprises the subject and the session date time. And we'll insert that dictionary into the session table. And if we print the contents of the session table, we can see what was entered in. The session directory table, it has a foreign key reference to session, and the secondary attribute is the session directory. So where's our data stored for this specific session? We will insert an entry into the session directory table. So we have the session key as well as the session directory. So subject one, session one is the relative directory of where this data is stored. The recording table stores information about the specific recording. So we assign a recording ID, as well as the equipment, acquisition software, and the recording directory. In this case, our recording directory will be the same as the session directory. So we create a recording key using the session key as well as a recording ID. And then we insert into the recording table the equipment, the acquisition software, and then we see that the recording directory is the same as our session directory, subject one, session one. And we can print out the contents of the recording table. And we see that it's entered in. And if you note, the primary keys are in black here in heading, and the secondary attributes are in white heading. Next, we'll be populating the recording info table. And we can see here that it stores the secondary attributes, the number of channels, the number of frames, the dimensions of the image, the frame rate, and so on. We'll be creating a dictionary called populate settings. And the display progress will be set to true. And then we'll populate the recording info table with the populate method because it's an imported table. And we'll pass in the argument of display progress. So it'll show us the progress of this table as it's being populated. And we can see here, after it's done populating, the recording info table stores all the metadata about this acquisition, including the frame rate, gain, and so on. Next, we will create a dictionary with the parameters. These are example parameters that Kaiman has prescribed for Miniscope CNMFE analysis. So we've copied them here as an example. And we will insert these parameters into the processing param set table with the insert new params helper function, which ensures duplicate parameter sets are not inserted into the table. So the processing method is Kaiman. The param set ID is 0. We have a description and then the parameters as well. Next, we will insert into the manual processing tasks table with the insert one method. This table designates which recording we'll be running the analysis for and which parameter sets we'll be running on that recording. So in this case, we'll be passing in the recording key that we defined above. we'll be using param set 0, which we just defined above. We'll be giving an output directory. So in this case, subject 1, session 1, Kaiman. And then task mode basically tells the downstream tables to either load data that was already run through Kaiman, but it can also be set to trigger, which means actually run Kaiman analysis for the parameter set ID that we specify here. So in this case, we've already run Kaiman, and we'll be loading in the data into the downstream tables. So the processing table is a computed table, so we'll run the populate method on it. And this table, when task mode is equal to load, it ensures that the Kaiman data is found. If task mode was equal to trigger, this is where Kaiman would be triggered for that particular parameter set and recording. Next is a curation table, which allows for a user to curate the Kaiman results outside of the element and then ingest that data into the downstream tables. In this case, we've opted not to curate our results. And so we'll be entering in the recording key, the parameter set ID, curation ID is 0, curation time, in this case is just an arbitrary time. The output directory is the same as our process directory. So subject 1, session 1, Kaiman. And because we didn't curate it, we set this manual curation attribute to false, and there's no curation notes. So next is the motion correction table, which will load in the data that was run through Kaiman, specifically the motion correction shifts, in this case, rigid motion correction, as well as the summary images like the average image. The next table is the segmentation table, and that will load in the data from the mass. And the next table is the fluorescence table, which will load in the traces from each one of the mass. And the last table here is the activity table, which will load in the deconvolved neuronal traces for each mask and store that data in this table. So this was a quick run through of how to ingest data into the DataJoint element for Miniscope analysis, including the metadata about the acquired image, as well as the process results through Kaiman, specifically for the UCLA Miniscope. So in the next set of videos, we'll be describing how to query, fetch, and plot the data that we just ingested. Thank you.